In Lesson 2.9, we're going to be talking about percent. We're still in Unit 3, more types of equations. Our big idea, still big idea number 1, basic algebra concepts review. Our guiding questions, number 1, how do you write a percent as a fraction? Well, since a percent is a percentage of 100, then you write a percent as a fraction as whatever it is over 100. And number 2, what concept can you use to solve percent problems? We use our concept of proportions. We use our concept of proportions to help us solve percent problems. And as for the other question above, I should have written this down when I talked about it. If I'm talking about 50%, 50% as a fraction means 50 over 100. So we know as a fraction, percent is whatever you're talking about over 100. Our enduring skills here is math practice standard number 3, construct viable arguments and critique the reasoning of others. And how will we be doing this in this lesson? We'll be using our previous knowledge of proportions to construct how percents work. And what is the percent proportion? The percent proportion says that you have whatever percent you have over 100, and we've already talked about that. That's what it means to write a percent as a fraction. Percent over 100 equals part over whole, which is the same thing as is over of. And the whole is also sometimes called the base. So a good way to remember this is percent over 100 equals part over whole, which is over of. So how can we use this to help us solve percent problems? If you know 3 of the 4 parts of the proportion, you can find the 4th part. So we know we're always going to have percent over 100 equals is over of. So of those remaining 3 parts, if I know 2 of those, then I can fill them in and solve for that remaining 4th part, because I know 100 will always be there. I will always have some part of the percent over 100. So if I look at problem 1 here, finding a percent using the percent proportion, it says what percent of 56 is 52? They're asking me what percent. So if I go ahead and write out my parts of my percent proportion, I don't know the percentage here. So that's what I'm looking for. What percent? That's my X. Of 56, 56 is my of, is 42. So now I have my proportion set up. So now I can just do my cross products and solve. So I'm going to multiply X times 56, which gives me 56X. And then I'm going to multiply 100 times 42, and that gives me 4,200. And then to get X by itself, I divide both sides by 56, and I get X equals 75. So what percent of 56 is 42? 75%. So now the got it problem we have here, what percent of 90 is 54? Again, if I set it up, it's just a matter of filling in my spots. What percent, so that's my x, of 90 is 54. So then I'll multiply it. 90 times x is 90x. 54 times 100 is 5400. And 5400 divided by 90 gives me 60. So what percent of 90 is 54? 60%. Now sometimes I may not always be finding the percent. I may be finding a part. If I look here at problem 3, it says a dress shirt that normally costs $38.50 is on sale for 30% off. So what is the sale price of the shirt? So in this case, I know I'm talking about 30%. So I have 30 over 100. Its normal cost, its whole cost, is $38.50. So that goes down here in the denominator on my right side. And I don't know what that 30% of $38.50 is, so that's what I'm finding here. So I'm finding the part, or my is. So now again, I'll do my cross products. 100 times x is 100x. 30 times $38.50 is $11.55. Divide $11.55 by 100, and we get $11.55. So that's what my 30% is. But they ask me what is the sale price of the shirt. So that means I need to take my normal cost, $38.50, and subtract my 30%, which is $11.55. So I get $38.50 minus $11.55, and I find out that my sale price of my shirt is $26.95. That is the sale price of the shirt. Okay, so if I look at the got it problem here, a family sells a car to a dealership for 60% less than what they paid for it. They paid $9,000 for the car. So for what price did they sell it? So first, again, I'm going to set it up. I know they sold it for 60% less, so I've got 60 over 100. I want to know what 60 is of the whole price, which was $9,000. So I've got my x in my part, or my is part. So again, do my cross products. 100x equals 60 times 9,000. And I get 540,000 divided by 100. And I get x equals 5,400. So 5,400 is 60% of the 9,000. So I need to take that 9,000, subtract that 60%, and I end up showing that they sold the car for $3,600. Now problem 4 deals with finding a base, or the whole, if we think of part or over whole. So in this case, I have my percentage, 125 over 100, equals my part, 17.5, of what number is what I don't know. So now I'll do my cross products. 125 times x is 125x. 100 times 17.5 is 1750. Divide 1750 by 125, and I get x equals 14. So does it make sense that 17.5 is a part of the whole of 14? Well, if we think about it, 125% is more than 100%, so it makes sense that my part is more than my whole, because in my percentage of 125 is more than my 100% percentage. So yes, that does make sense. Okay, if we look at guided problem 4, again, 30% of what number is 12.5? And we're just going to solve it using our percent proportion. We're not going to use the percent equation, so we'll just use our percent proportion. We have 30% over 100 equals, the part is 12.5. I don't know my of. So again, do my cross products. 30 times x is 30x. 100 times 12.5 is 1250. 1250 divided by 30 is 41.6 repeating. Now, a common application of percents is simple interest, which is interest that you earn only on the principal of an account. And if we look here, we have a formula. I equals PRT, where I stands for the interest, P stands for the principal, and R is the annual interest rate, which we write as a decimal, and T is the time in years. So if we look at the example, if you invest $50 at a simple interest rate of 3.5% for 3 years, the interest you earn is I equals 50, my principal, multiplied by my interest rate of 3.5%. 3.5% changed to a decimal is going to be 0.035. You move your decimal place 2 to the left when changing your percentage to a decimal, and then multiply by my period of time 3, which gives us a simple interest of $5.25. So now we'll look at this last problem here. You deposited $840 in a savings account. That's my principal. I earned a simple interest rate of 4.5%. That's my interest. You want to keep it in the account for 4 years. That's my time. So knowing my formula, interest equals principal times interest rate times time. I've got that my interest here will be 840. If I change 4.5% to a decimal, I move my decimal place 2 to the left, which means I will have as a decimal 0.045 times my time of 4 years. So I'll multiply 840 times 0.045 times 4, and I get the interest over a 4-year span for $840 at 4.5 would be $151.20.